Welcome to our web tutorial. Today we are going to be talking about bridges. So you should be writing these notes on a sheet of notebook paper, page 57. Make sure that when you come into class you get your spaghetti bridge worksheet from out of your hanging file. So Newton is someone that we introduced last unit, and we talked about three of his laws. Now, when it comes to building a bridge, the first concept that the builder has to grasp is Newton's third law. Newton's third law states that when there is an action that is created, there is an equal and opposite reaction. So imagine, if you will, swimming. When you swim, you push your arms down to your side, which are going away from you, and your body propels forward. The major forces that are going to be involved in building a bridge are going to be the weight of that object, force from the normal force, or from the supports, excuse me, that's the normal force, tension, and compression. So, weight and supports. So, it's very important that we know the weight of the object and we know what force the supports can take for that object. So, the bridge or the roadway itself is going to have weight. So, like with everything that we've done so far, we assume that the majority of the weight, which is F of G, is being exerted within the center of the bridge. The supports, which are F of N, must exert an equal and opposite reaction to the weight so that the bridge will not collapse. So here is a picture of our bridge. We see that our bridge has its own mass. So just as you are sitting on a table, not on a table, excuse me, you're leaning on the table or you're sitting on the chair, that chair is exerting a force back up on you. So those chairs are going to hold a certain mass. So you yourself who's sitting in the chair may not be as massive as the person before you, or maybe you're more massive than the person before you. But the designer of the chair had to make sure that the people who sit in this would go up to a certain mass or weight. Then we have our weight and our supports that we're continuing to talk about. Now, on a bridge, obviously a bridge is made so that objects can get from one side to another. That's not possible otherwise. So when we have bridges that are built, we have them built so that cars can travel on them. So our supports must exert more force than just the weight of the bridge itself. We have to do this in order to keep the bridge from collapsing. So here's an example. We say that the overall weight of a bridge is 500 newtons. That's not including cars, buses, and so forth. And the bridge is going to have two supports. So you see over here that we have one support, support two. We are asked how much force is each support exerting. Well, we know that the bridge itself is 500 newtons. So if we take 500 newtons and we divide it by 2, we get 250 newtons for each of our supports. There we go. And so our F of G was given to us, 500 newtons. Then A, that should be B, then B says how much force does each support need to exert when there is a force of 600 newtons due to cars, buses, and etc. So we have an additional force that's going to be pushing down on this bridge, and we have to account for that, just like the chair designer had to account for all the different masses of the different types of people that would sit on the stool that you're sitting on. So this question can actually be thought of two different ways, and I'm going to do it this way. If our bridge is 500 newtons, okay, and the extra force that will be added to it is 600 newtons. So this is the designer trying to account for the number of cars that can be on the bridge at one time. That's going to equal 1,100 newtons of force on that bridge that may possibly happen at one time. So if that is the case, then we're going to take our new total force that could be on that bridge and we're going to divide it by 2, and that's going to give us a new number of 550 newtons. You could have done this another way of you could have split the 600 into 200 and added that to the 250, which would have been 350 as well. So compression and tension. So here's two definitions that you're going to need to write down. Compression is a force that acts to compress or shorten the thing it is acting on. Tension is a force that acts to expand or lengthen the thing it's acting on. There is compression at the top of the bridge and there is tension at the bottom of the bridge. Thus the top portion extends up, being shorter, it's compressing together, and the lower portion then is longer. The tension is going to be being created by the supports here, and it's kind of pulling them out.